All right, so I've got a couple more definitions and a couple more examples that I want to do having to do with continuous. First off, I want to do continuous from the left. And it sounds like what it is, that the limit as x approaches n from the left of f of x is the function's value. And if I do continuous from the right, it's going to be the same kind of thing. The limit as x approaches n from the right is that function's value. Now, you're going to ask me, Mr. Harold, why am I talking about continuous from the right and from the left when I could just say continuous? Well, the answer is this, the square root function. Think about it carefully. If you look at 0, you plug in square root of 0, you're going to get 0. So the function's value is 0. However, it's not defined for negative numbers. So you can't plug in anything to the left. The two-sided limit doesn't exist. However, the limit as x approaches 0 from the right does exist. So the square root function is continuous from the right at 0, but it's not continuous all the time at 0. So the other thing that I want to talk about right now is continuous on an interval. If I write an interval in parentheses from a to b, what that means is it's continuous on every number between a and b, but not a and b, okay? Let me say that again. It's continuous between a and b, but not a and b. If I write it like this, with brackets instead of parentheses, it's continuous between a and b, and it's also continuous from the right of a and left of b. Now you're probably thinking, but Mr. Harold, that's a little bit backwards, and you're kind of right. Here's the thing. I'm starting at a, and so I want to, in this case, this is the left one, I want to be continuous on the right side of it, so it's connected to the rest of it. And b is the right number, so I want to be continuous from the left side, so it connects to it. All right, so now that I've got those definitions and that explanation out of the way, I'm going to go ahead and talk about these examples. So what I'm going to do first is this example, f of x equals the square root of 16 minus x squared. And then I'm going to figure out where it's continuous. I'm also going to do this one over here, which is a rational function, but I'm going to get to that in a second. So first and foremost with this one, this is where some limit laws are going to come in handy. Now, I'm going to point out to you that there are some numbers that you just can't plug in here. For instance, if you tried to plug in, I don't know, let's say 6. If you try to plug in 6, you're going to get 16 minus 6 squared. 6 squared is 36. 16 minus 36 is negative 20. And the square root of negative 20 does not exist. It's undefined there. So the question is, what numbers is it defined for? I need to check that first. Well, if I think about it, it's defined on these numbers. Negative 4 to positive 4. Why? Because think about it. If you plugged in 4, 16 minus 4 squared, that's 0. If you plugged in negative 4, 16 minus 4 is 0. But any numbers bigger than 4 or smaller than negative 4 are going to make it a negative number under the square root, and that's not going to work. So what I need to do right now is think about what happens between these two numbers. What's happening in between them? So this, at this point in time, would be a great time to think about your limit laws. So here's what I'm going to do. I'm going to think about my limit laws for a second. So if I think the limit as x approaches n for f of x, that means what I can do is I can kind of move my limit around in there. So I'm going to think about it. The limit as x approaches n of the square root of 16 minus x squared. Well, one of our limit laws said the square root doesn't matter. I can just move my limit inside. So that's what I'm going to do. I'm going to move the limit inside the square root. Now, next thing I'm going to do, I'm going to break it up. If I'm subtracting or adding, I can take the limit of them separately. So that's what I'm going to do. Square root, and I'm going to do the limit as x approaches n of 16 minus the limit as x approaches n of x squared. Now, here's the thing. In this case, we're taking the limit of a constant number, in this case 16. So that answer is just 16. The other thing that we said was if we have x to an exponent, it's just going to be n squared. Well, that's the function at n. So that's the thing. It's essentially like plugging in the numbers and seeing what happens. And so I wanted to use all of my limit laws to make sure everything worked out nicely. But now, that shows me everything between negative 4 and positive 4 are going to work. But what's going to happen at negative 4 and at positive 4? All right? So let me just think about it for a second. If I think about plugging in positive 4, like I said, we get 0. Here's the thing. Again, we cannot plug in any bigger numbers and see what happens because it's not defined from the right side. Here's the thing. I don't care if I'm looking at 4. I don't care if it's defined on the right. I want to make sure it's defined on the left. Well, we said it was. We said that any number less than 4 is going to work. And if you plug those in, we just said they work. You can always test it numerically or graphically. Again, this has to be continuous from the left. And I know that it is. Its value is going to be 0, and it's approaching 0. This -4 has to be continuous from the right. Again, you can test it graphically or you can test it numerically, and it's still going to work the same way. It's going to be approaching 0. So here, this right here is my continuous interval. Notice the brackets, not the parentheses, from -4 to 4. I'm also going to go ahead and look at this other one, g of x plus 1 over x minus 1. I want to go ahead and check what interval it's continuous on. Now, first and foremost, hopefully you guys are thinking about it from the last example. I know right off the bat that x is not defined for 1. So I know that that's going to be an issue. Now, here's the other thing. What I can do is, again, apply my limit laws for any other number, okay? So I'm going to look at x plus 1 over x minus 1. What I'm going to do, if you guys remember, I can't have a denominator of 0, but I've already taken care of that. X can't be 1. So what I'm going to go ahead and do is move my limit to the top and the bottom. So limit as x approaches, I'm writing it down, x approaches n of x plus 1 over the limit as x approaches n of x minus 1. Again, adding or subtracting doesn't matter. You can split it up and do the limit that way. So limit as x approaches n of x plus the limit as x approaches n of 1 over big long one limit as x approaches n of x minus the limit as x approaches n of 1. Remember, constants just come out the same number. X has come out as n, so I'm going to kind of go backwards here. And I'm going to get n plus 1 over n minus 1. Well, that's just, I'm writing F instead of G. That's just the function's value at n. So yeah, it's continuous for all of those numbers except 1. So how do I write that as an interval? Well, good question. I'm going to go ahead and erase a little bit so I can write it down. My continuous interval here is going to go from -infinity to 1 and 1 to infinity. Notice, I'm not putting brackets, I'm putting parentheses. Parentheses saying you can't reach infinity, which is very true. You're never going to reach infinity no matter how long you count. So, -infinity to 1. Again, can't be 1. Can't be 1, so I put a parentheses and infinity. Hopefully you guys help understand this stuff. If you have any questions, please let me know. Again, make sure you pay attention and use your limit laws. That's why we did them. So, have a great day.